Good morning, people. We should be live now. Let me go ping the Discord. Audio sounding fine for everybody? Bacon hears me. Cool. All right. Hey, Redstone. Jose Cuadrado. Hold on. You guys shouldn't see that. All right, let me just get some stuff set up while we wait for some more people to trickle in. Hey, Bacon knows Spanish. Who knew? What do I do here? Oh, not that. This. I lived for 4 years in Costa Rica. And oh, Portuguese. Who knew? Yeah, I don't know any Portuguese. Just a little bit of Spanish. Thank you. Yeah, Bacon, you and I are like trying to talk Spanish to this Portuguese guy. That's funny. What build system am I going to use? I don't know. You don't know any Portuguese either? Yeah, if I'm like in a plane or something and the announcements are in Portuguese because I'm flying through Brazil or something, then I probably get like 40 or 50% of the words just because it's so similar to Spanish, but just like I don't get it. Yeah, at least we didn't guess he's German. Yeah, it's pretty similar to Spanish. I have Spanish friends that say they can understand Portuguese fairly easily. Okay, well, I'll get started here, I guess. As soon as I can get this something out of my throat. Okay, so where were we? We were... Okay, I gotta find my book. Here we are. So, if I recall correctly, look at this loveliness. Connor says he doesn't know how helpful this chapter on finite state machines and regex will be for making an OS. Hey, Kat. What do you guys think about Connor's comment? Do you think this is sort of an unrelated? Regex is the best. Wait, what does this have to do with regex? Oh, sure enough. Regex. You agree with Connor? So you think I should just not do it? If I don't do it, that means we're starting C today. How does that make you guys feel? Uncomfortable? Because look, it's like this chapter, which is about like fourth, whatever that is. And then the next, and then it's C. So let's do a poll, no? Should I skip finite state machines and go straight to C? Boom, here's our poll. By the way, you guys probably want me to cast my keystrokes. There we go. Stick that right there. Okay. It's working. All right, yes is definitely winning. It'll be useful for driver dev. Okay, well, I can always come back to it, right? So there's not really any harm in skipping stuff that I can come back to. Unless it would like help me understand C, but I don't see how it would. Okay, well, let's do some C. Question why? Are you asking why it'd be helpful for a driver dev? I don't know. I've never written drivers. All right, we're doing C. Do you think I can do this locally? Or do you think I have to be in code space? I'm gonna try to do as much as I can locally, which means I gotta do this. Okay. Let's have this low level thing. It's kind of just like a scratch pad. Yeah, right now we just have that. Let's just get rid of all that. Okay, let's learn some C. In this chapter, hold on, let me make sure the stream is okay. Is it just me or is my name like floating? Like right here? With no text next to it? Oh well. In this chapter, we are going to start exploring another language called C. It's a low-level language with quite minimal abstractions over assembly. At the same time, it is expressive enough so we could illustrate some very general concepts and ideas applicable to all programming languages, such as type system or polymorphism. C provides almost no abstraction over memory, so the memory management task is the programmer's responsibility. Also known as manual memory management, no, which is what I'm pretty strongly leaning towards lovely being, is manually memory managed. Unlike in higher level languages such as C# or Java, the programmer must allocate and free the reserved memory himself instead of relying on an automated system of garbage collection. C is a portable language, so if you write correctly, your code can often be executed in other architectures after a simple recompilation. The reason is that the model of computation in C is practically the same old von Neumann model, which makes it close to the programming model of most processors. When learning C, remember that despite the illusion of being a higher-level language, it does not tolerate errors, nor will the system be kind enough to always notify you about things in your program that were broken. An error can show itself much later on another input in a completely irrelevant part of the program. Device drivers in an OS often use FSMs, finite state machines, to represent the different states of the hardware they control. For example, a network driver might connect states like disconnected, connecting, connected. Gotcha. That's helpful. Language standard described. The very important document about the language is the C language standard. You can require a PDF of the standard draft online for free. Okay, we'll get that if we need it. Before we start, we need to state several important points. It's always case sensitive. Does not care about spacing as long as the parser can separate lexemes from one another. This program, shown in listing 8.1 and listing 8.2, are equivalent. Okay, that's fine. There are different C language standards. We do not study the GNU C, a version possessing various extensions, which is supported mostly by GCC. Instead, we concentrate on C89, also known as ANSI C or C90, and C99, which are supported by many different compilers. We also mentioned several new features of C11, some of which are not mandatory to implement in compilers. Unfortunately, C89 still remains the most pervasive standard, so there are compilers that support C89 for virtually every existing platform. I think when I learned C before a little bit, it was C99. Does that sound right? This is why we will focus on this specific revision first and then extend it with newer features. To force the compiler, less where will you upload the other days on your YouTube? I can only see the days up until day 8 or something. If you go here, let me show you. This is kind of annoying, but and I thought about just like uploading them straight, but then I kind of decided not to. So look, if you go to my YouTube channel, how do you go to my YouTube channel? Hang on. Don't look at this. YouTube channel. Okay. I guess it doesn't really matter if you guys see that. No. And then you go to live, right? See how it says live streams are under the live tab. You go to live. They're all here. Because originally I was just recording them and uploading them, and then I switched to doing these live streams. So now they're under the live tab. Or if you just go to the playlist and you go to like creating an OS from scratch, then they're all here in the playlist. This is the current one. So cool. But yeah, they're all there. They're all free. Okay, to force the compiler to only use those features supported by a certain standard, we use the following set of flags. -stud equals C89 or -stud equals C99 to select either C89 or C99 standard. -pedantic errors to disable non-standard language extensions. -wall to show all warnings no matter how important they are. That's probably warning all, not wall. -warning error to transform warnings into errors so you would not be able to compile code with warnings. Interesting. Yeah, there's a playlist, Bacon, there's a playlist for the OS dev, and there's a playlist for Lovely as well. There's 2 playlists. Hello, Arik Fajar. I don't know if I pronounced that right. Probably not, but... warnings as errors. It's very bad practice to ship code that does not compile without warnings. Warnings are omitted for a reason. Sometimes, yeah, this is kind of a universal concept, I think. Okay. For example, to compile an executable file main from source files file1.c and file2.c, you could use the following command. Okay. This command will make sure full compilation pass, including object, file generation, and linking. Program structure. Any program in C consists of... I pronounced it right? No way. Awesome. That's where... Okay. Thank you so much. That's very useful. I have no idea how I stumbled on this while researching post-quantum encryption, but I'll for sure come back to these streams. I think this was the fastest subscribe I ever did. Awesome. Thank you so much. Yeah, I'm not sure... I have no idea what post-quantum encryption is, but may I know what's the end goal for building this? The end goal is to learn along the way. But as far as like the operating system goes, I'd like to have something kind of nice. I don't know. Probably won't end up being anybody's daily driver, but it might have a GUI. Who knows? These kinds of things, I feel like they're never like done. They just kind of keep going. Will you start your kernel in C and replace it by your language Lonely little by little, or dev a core in C and write more high-level constructs in Lonely? I want to do the whole thing in Lonely, because Lonely is going to be a really low-level language. If I end up feeling the need for a higher-level language, then I can make another language. Sorry, not Lonely. Lovely. I keep calling it Lonely. I always forget that we changed it. So yeah, I'd like to do the whole thing in Lovely if I can. All right, and then it's encryption that stands up to quantum computers. Okay, I had somebody else tell me in a comment once to do something with quantum computers, and I was like, no. Any program in C consists of data, types, definitions, structures, new types, etc., which are based on other existing types. For example, we can create a new name, new int type name t for an integer type int. Okay, type def int new int type name t. Okay. Global variables declared outside functions. For example, we can create a global variable, I am global of type int, initialized to 42 outside all function scopes. Note that global variables can only be initialized with constant values. Int I'm global equals 42. Okay. Functions, for example, a function named square, which accepts an argument of x and type int and returns its square. Comments. And then these things. Fun. Inside functions, we can define variables or data types local to this function or perform actions. Each action is a statement. These are usually separated by a semicolon. Actions are performed sequentially. You cannot define functions inside other functions. Statements will declare variables, perform computations and assignments, and execute different branches of code depending on conditions. A special case is a block between curly braces, which is used to group statements. Listing 8.3 shows an exemplary C program. It outputs hello world, y equals this, and x equals that. It defines the function main, which declares two variables x and y. The first is equal to 43. The second is computed as the value of x and y. Okay, yeah. Function printf is used. Yep, I know this. Okay, you use dash %d for ints and %f for floats. Perfect. Okay, variable declarations, assignments, and a function call. Yada yada yada. Spare printf for format output. Whenever possible, use puts instead of printf. This function can only output a single string. It ends with a new line. No format specifiers are taken into account. Not only is it faster, but it works uniformly with all strings and lacks security flaws described in this section. He kind of just glanced over the preprocessor macro. This guy? You talking about this? I feel like I saw it. For now, we will always start our programs with the line include standard IO. Okay. Allows us to access part of the standard C library. Yeah, they're defined. This thing? Shoink. What is this doing? Is it a preprocessor macro with arguments? Is that what it's saying? Yeah, it is. Okay. This is a comment. All right. However, we state firmly that this is not a library import of any sort and should never be treated as one. Okay. I won't treat it as one. Let's write some C. include standard io.h. What language server is even running? Oops. SourceKit, which is the Swift one that also I guess works on C. What do you guys recommend for a Milk is a professional macro abuser? Great. What do you guys recommend for a C language server? What's the best C language server? Clang D. I'm getting a lot of Clang D. Let's go check out Clang D. Let's go to this guy here. Whoa, what's going on here? Okay. Hey. Hey, look, Bacon. Bacon, is this you? You have your own language server? Think I can get that in Discord to decipher your messages? Okay. Clang D, this guy? Clang D. Defaults are probably good, no? Probably need to install it. Clang D. Mac OS. Oh, does it come with wait. Sure enough, I already have it. Okay. Let's go over to .files. Plugins. Where is it? LSP config. Where's SourceKit? Can I like turn this off for? See. All right, well, anyway, we'll do, wait, this is Astro. I need to comment this better. Astro. Okay, and then we'll have C lsp config dot, what is it? Clang D dot setup. And then I just need to pass along the capabilities. And maybe that'll be enough. File types capability. Okay, here I can do this. This will be better. So here I want to just turn this to be, wait, let's find a SourceKit in here. SourceKit. This guy. See how this guy's turned on for C? So let's turn that off. File types. Make that be just Swift and maybe Objective C. And maybe Objective, what is Objective C++? That's fine. I'm never gonna write those, so just want it for Swift. So we should have Clang D now. So if I quit out of here and go over to low level, and then if I quit out of that, open up this guy, and then now we have Clang D. Perfect. It's a little bit ugly because it's not quite fitting onto one line. Oh well. It's all right. So now we keep going. So we have this, and then we have our main. Oh, cool. There's a nice little snippet. We don't need those yet. Just do void. Okay, how do you guys format your C code? Do you do it this way or do you do it this way? This way or this way? And where can I get a good formatter? Any good C formatter recommendations? We have LSP working great, but we need a formatter. Clang format. Okay. Jump over back to our dot files. And here, conform. Okay, wait. How do I know? Okay, where is clang format? Where can I get clang format? Clang format? Is this it? I want to download. Is it in Clang Tools Extra? How does one download Clang format? Oh, it's in Homebrew. Perfect. Dun, 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 dun. Now we have it. Okay, and then I'm going to say if the file type is C, then use Clang format. Wonder if that worked. Low level. Okay, quit. Oops. Quit out of here. Open this again. We had a warning. But now it's probably not going to show. Oh wait, that worked. Sure enough, it's working. Okay. Milk, almond syntax? Which one is almond syntax? C, almond syntax. This is almond. Whoa, there's a lot. This is kind of like the traditional way to do it, isn't it? Some of these look so bad. Like, whose idea was? So K and R, I guess, is like the normal language thing. Yeah, okay. It looks like this is doing, if I did like int foo equals 3 up here, this is doing K and R by default, I guess. So we'll just stick with K and R. Yeah, K and R. So we'll do this. Now we want int x is 43 and y is, sorry, we don't do that. We say y equals x minus 1, and then we're gonna printf. Hello world, y equals %d, x equals %d. New line, y, x. Isn't that nice? Would I get an error if I did that? I did. Whoa. Cool. So we should run this thing. How do we run this thing again? Where is that? This, like this? GCC. That worked. Cool. All right, we did this. Literal is a sequence of characters in the source code which represents an immediate value. In C, literals exist for integers. Yep. Floating point numbers. Yep. ASCII code characters. Yep. And pointers to null. Yep. Okay. So these are pointers to null terminated strings. That's right. It's like a char star. So I could say like char star foo is this, no? But I would have, so how does this format it? Like that or like that? Like that, okay. You missed pretty much every single flag. Yeah, I did intentionally leave out the flags. Should I add them? Like this. Let's try it again with the flags. We're gonna go dash ANSI. Wait, what was the ANSI one? It didn't say what the ANSI one was. You really know what ANSI is? And then pedantic errors which disable non-standard language extensions, okay? And then show all warnings and turn warnings into errors. Yeah, it still works. There we go. This is where I make a just file. You like GCC hello, or not hello. We'll do like out. And then we'll do that. We could clean it up too, but we'll leave it for now. So now if I just run, what is it? Hello. It works. Cool, this is so fun. Okay. What a nice language. Okay. Program structure. Wait, we already did that. We're down. Okay, the execution of any C program is essentially a data manipulation. The C abstract machine has a von Neumann architecture. It is done on purpose because C is a language that should be as close to the hardware as possible. The variables are stored in the linear memory, and each of them has a starting address. You can think of variables like labels in assembly. ANSI is the C standard. Oh, okay. You should also have -G-O0 so that it's easier to debug if you plan on doing that. Okay. ANSI is the American standard. Gotcha. As pretty much everything that happens is a manipulation on data, the nature of the said data is of particular interest to us. All kind of data, yep, has a type. Typing in C is weak and static. I like static. I don't like this weak so much. Static typing means that all types are known on compile time. There can be absolute incertitude about data types. There can be absolutely incertitude about data types. What? Whether you're using a variable, literal, or more complex expression which evaluates to some data, its type will be known. Weak typing means that sometimes a data element can be implicitly converted to another type when appropriate. For example, when evaluating 1 plus 3.0, it is apparent that these two numbers have different types. One of them is an integer, the other is a real number. You cannot directly add one to another because their binary representation differs. You need to convert them both to the same type, probably a floating point number. Only then will you be able to perform an addition. In strongly typed languages such as OCaml, OCaml referenced. This operation is not permitted. Instead, there are two separate operators to add numbers. One acts on integers, yep. The other written, yep. Stefan, the book said that it was going to start on C89 since that was the most pervasive, and then it said it was going to add on to it with like C99 features and maybe C11 features. Weak typing is in C for a reason. In assembly, it is absolutely possible to take virtually any data and interpret it as data of another type. Pointer as an integer, part of string as an integer, etc. Let's see what happens when we try to output a floating point value as an integer. The result will be the floating point value reinterpreted as an integer, which does not make much sense. This program's output, okay, so it would do that. That's interesting. All types in C fall in one of these categories. Integer numbers, int, char, etc. Okay. Floating point numbers, double and float. Pointer types, composite type, structures and unions, enumerations. Yes, I'm not familiar with how to do these in C. Surely we'll get there. In chapter 3, we are going to explore the type system in more detail. Perfect. Sorry, chapter 9. Did I say 3? If you come with a background in a higher level language, you might find some commonly known items missing from this block. Unfortunately, there are no string and Boolean types in C to 89. Didn't they add true and false later on? An integer value equal to 0 is considered false. Any non-zero value is considered truth. Okay. Control flow. According to von Neumann principles, the program execution is sequential. True and false are part of standard bool. Okay. A compiler can support C23. The program execution is sequential. Okay, yep, they're executed one after another. I might go sort of fast through some of this stuff, guys. One, because I already kind of know C, and two, because this is pretty basic, like language stuff that's sort of universal. Like if so, okay, but real quick, like what in the world does x greater than 3 evaluate to if it's not a Boolean? Is it 1? Does this just evaluate to 1? We need to do some stuff in here. Okay, hold on. Oh wait, that's not how this works. If I said like int foo equals x greater than 3, yeah, everything but 0 is true. So this becomes 1. Sorry, there's no x. 54. But if I had said like char star, integer to pointer conversion, perfect. Okay, so it is an integer. It's probably just 1, no? Oh yeah, it says the value? What? What is this? Wizardry. How smart is this language server? Okay, it doesn't know this one. Yeah, okay. Okay. So only when it's like literally a bunch of stuff like this. Gotcha. Okay, so it is 1. That's good to know. So if you just stick in something in here, and if it's 0, then it says nope, and if it's yes, then it runs this. Perfect. And you can do else. I don't like how this is formatted though. Am I going to try to format it that way? Because that's bad. If I say int x gets 100, oops. If x is greater than 3, then we're gonna puts hi else puts by. Oh dear. Yeah, okay, mine formats it nicer. Perfect. All right. Braces are optional. Without braces, only one statement will be considered. Oh, that's interesting. It's like JavaScript. I guess you don't need that, and you don't need that. I guess you do need those. Okay, never mind. I lied. Intriguing. Notice there is a syntax fault called dangling else. Check listing 8.7 and see if you can certainly attribute the else branch to the first or the second if. To solve this disambiguation in case of nested ifs, use braces. You might have considered one of the following. Wait. Oh, yeah. That's interesting. That is a syntax fault. A while statement is used to make cycles. Okay. That's fine. I'm guessing all variables are mutable. Is that what this means? Oh, but isn't there like a const keyword? What does const do? Okay, well, for now at least, all variables are mutable. The condition is satisfied, yada yada yada. You can also do while. Yup, okay. This is the same thing, but you check it afterwards. For, we all know C style for loops. Oh dear, but here's a race. The type syntax is pretty horrific. Okay, so you say like int a equals this. And you go like 1, 2, 3, 4. Okay. And then in here you can give it a length maybe. What if I stuck, 67 in there? Yeah, then it's an array of like that. But I guess I can just infer that. If I stuck the 4 here, I wonder if I'd be able to put this here. Eh? Nope, I can't. Okay. You gotta do it this way. Interesting. So this is an array. And then you can loop through it. And I'm guessing this ends up just being like a pointer to the first one, maybe. Const makes them immutable. Okay, cool. Then there's a condition check. Hold. Okay. Increment operator. We know that increment operators. Anything new or interesting in here? Not really. Okay. Break statement. Oh yes, we know about break. These can be left empty, and this will loop forever unless a break. Okay, that's interesting. I do kind of remember this actually. You can leave stuff empty in here. Go to. Oh dear. So go to statement allows you to make jumps to a label inside the same function. So this is just like, it has to be in the same function. But it's just like assembly. As in assembly, labels can mark any statement. Syntax is the same, label : statement. This is often described as bad code style. However, it might be quite handy when encoding finite state machines. What you should not do is to abandon well thought out conditionals and loops for go to spaghetti. Sure. But it is an option. You label things like this, joink, and then you can go to. Cool. Go to statement mixed with the imperative style makes analyzing the program behavior harder for both humans and machines. So the cheesy optimizations the modern compilers are capable of become less likely. Why cheesy optimizations? And the code becomes harder to maintain. We advocate restricting go-to usage to pieces of code that perform no assignments, like the implementations of finite state machines. Okay. Whoa, there's switch? I didn't know there was switch. A switch statement is used like multiple nested ifs when the condition is some integer variable being equal to one or another value. Listing 8.15 shows an example. You switch on this and then you can check values. But it's more like a JavaScript. This is very JavaScripty. Okay. Every case is in fact a label. Whoa. These are labels. The cases are not limited by anything but an optional break statement to leave the switch block. It allows for some interesting hacks. However, One of the most known hacks is called Duff's device and incorporates a cycle which is defined inside a switch and it contains several cases. Okay, however, forgotten to break is usually a source of bugs. Listing 816 shows two behaviors. First, several labels are attributed. Okay. Then is the break is not ending. First, several labels are attributed to the same case, meaning no matter whether x is 0, 1, or 10, the code executed will be the same. Then, as the break is not ending this case, after executing the first printf, the control will follow to the next instruction, label case 16, another printf. So there's no break here, so it'd do both. You used a Duff device for a VM you made? No way. Example divisor. Provides that searches for the first divisor, which is then printed as standard out. The function first divisor accepts an argument n and searches for an integer r from 1 exclusive to n inclusive, such that n is a multiple of r. Okay, if r equals n, we have obviously found a prime number. Notice how the statement after 4 was not put between curly braces because this is the only statement inside the loop. The same happened with the if body, which consists of a sole return I. You can of course put it inside braces, and some programmers actually encourage it. I've heard that before. Okay. It's fun stuff. Example, is it a Fibonacci number? Ooh, I want to do this myself. Just a program that checks whether a number is a whether or not it is Fibonacci. This is different. The Fibonacci series is defined recursively. Yes. Use it in combinatorics. I did take a combinatorics class. Fibonacci, biological settings. Yeah. 1, 1, 2, 3, 5, 8, 13, 21, etc. Alright, let's try it. Let's give it a shot. We'll keep int main void for some reason. Return 0. And then we'll have int is fib is what they have, right? And takes int n. And you got to figure out whether it is Fibonacci. How do we do this? I feel like there's a lot of ways to do this. You could say like, or int cur value. Wait, do you use snake case or camel case in C? Do you usually use camel case or snake case in C? Snake case for variables and functions. Usually snake case, is that right? I do prefer snake case. Oh wait, look, my function's called is fib with snake case. Okay, problem solved. Cur value, and we'll do like previous value. Do opposite of what robot told me. Why? Except these are both 1 because we start out as 1. And then we'll say like while n isn't equal to cur value and is less than cur value, well, actually, we'll do this inside. Okay, well, n isn't that, then we'll say prev value okay, wait. Okay. Like the previous current value, I don't know if that's a good name, is cur value. Cur value becomes cur value plus prev value, and then prev value becomes prev cur value. Then we say, like, if cur value is greater than n, return 0. Here we'll return 1. Jose, gotta go. See ya. Take a look at Duff's device. It's interesting stuff. Okay. Thanks for the help, man. This might work. Who knows? So then we'll just make an example. Test. 13 is a Fibonacci number. We'll say int fib equals is fib test. And then we'll say, I guess we could just return this. Doesn't this make this the exit code? Just run hello.c, shoink. Exit code 1 because it is 1, but if I make it a 14, exit code 0, perfect. So it works. But that's probably not what you did. I forgot an edge case here. If n is 1, then I can return 1. Also, I forgot that I can leave off these. That's probably a little nicer now. All right. Cool. Statements and expressions. C language is based on notion of statements and expressions. Yeah, we know about this, I think. Which year are you in now at the university? Me? I'm not at a university. All literals and variable names are expressions. Yeah. Additionally, complex expressions can be constructed using operators and other logical, arithmetic, and bit operations. And function calls. Okay. Expressions are data. So they can be used at the right side of the assignment operator. Some of the expressions can also be used at the left side of the assignment. They could correspond to data entities having an address in memory. That's interesting. Such expressions are called L value. All other expressions, while having no address, are called R value. This difference is actually very intuitive as long as you think in terms of abstract machine. Expressions such as shown in listing 820 bear no meaning because an assignment means memory change. Why does this makes sense, sort of. This, oh, gotcha. That's interesting. That's kind of different. Statement types. Statements are commands to the C abstract machine. Each command is an imperative. Do something. Thus the name imperative programming. It is a sequence of commands. Yep. A block delimited by... Oh, so it can be expression terminated by a semicolon or a block. It contains an arbitrary number of sentences. A block should not be ended by a semicolon itself, but the statements inside it likely should. Here's a typical block. Shoink. Okay. Control flow statements, if, while, if, for, switch. They do not require a semicolon. There's assignments, for example, A equals B equals C. Assign C to B and assign the new B value to A. That's interesting. I didn't know that. A typical assignment is thus a statement from the first category, expression ended by a semicolon. Assignment is a right associative operations. That means when parsed by a compiler or your eye, the parentheses are implicitly put from right to left. Yep, okay. So it's like y equals z, and then you make that equal to x. On the other hand, left associative operations consider the opposite nesting order as shown. This is like these things. Yep. An expression is built using other expressions connected with operators and function calls. The operators can be classified based on arity, unary, binary, ternary. Oh, there's ternaries in C. Who knew? Based on meaning, arithmetic, relational, logical, bitwise, assignment. Whoa. Some of these are interesting. Miscellaneous operators. Size of R is replace this with the size of var in bytes. That's cool. Takes an address of an operand as what as dereference? This would be the star, right? You forgot something here. This is the ternary, which looks like the Elvis operator right here. And then this like points into the field of a structure. Ternaries are awesome. No. I don't think they're great. But we should do a poll. Are ternaries good? I don't really like how I can't vote in my own polls. Okay. Wow, you guys all like ternaries? My voice doesn't count, I know. I know, Bacon, I know. Most operators have an evident meaning. You love one-liners. We'll mention some of the less used and more obscure ones. Ternaries are the best for one-liners. Maybe. Unless you could do something like this. If, foo, bar, else, lorem. See, this is a little longer. What if you could do this? That's kind of ugly too. Okay, you're right about one-liners. But they, like, nesting them is a nightmare, for one. Ternary means 3 in Latin, by the way. Yeah, because it's like unary, binary, ternary, right? And then like a 4-way operator would be I don't know what. Quaternary. Alright, we know about increment and decrement operators and how they can be before and after. Difference between a logical and a bitwise operator. For logical operators, a non-zero number is essentially the same in its meaning, while the bitwise operations are applied to each bit separately. Yep. This is equal to 0 because no bits are set in both 2 and 4. However, 2 and 4 will return 1. Gotcha. So this is bitwise and this is not bitwise and. Logical operators are evaluated in a lazy way. Consider the logical and operator that. When applied to two expressions, the first expression will be computed. If its value is 0, the computation ends immediately. Oh, we know that. Yeah, that's true in other languages too, actually. Quandary. Quandary, that'd be funny. Okay. Tilde is a bitwise unary negation. Hat is a bitwise binary XOR. The following chapters will revisit some of these, such as address manipulation, operands, and sizeif. Okay. Functions. We can draw a line between procedures which do not return a value and functions which return a value of a certain type. The procedure call cannot be embedded into a more complex expression, unlike the function call. Listing. This shows an exemplary procedure. Its name is myproc. It returns void, so it does not return anything. It accepts two integer parameters named a and b. Okay. Small question. Are you making your own language to make your own OS using it? Exactly right. That's it. That's the goal. Listing 826 shows an exemplary function. Accepts two arguments. Yep. Okay. Perfect. It ends with your return. Otherwise, which value will return is undefined. Procedures can have the return keyword omitted. It will still be used without an operand to immediately return from the procedure. Sorry, it might still be used. Okay. Thank you. You're welcome. When there are no arguments, a keyword void should be used in function declaration as shown in listing here. Stick a void in here. That's kind of odd. The body of function is a block statement, so it is enclosed in braces and not ended with a semicolon. Each block defines a lexical scope for variables. All variables should be declared in the block start before any statements. That restriction is present in C89 but not C99. That's interesting. I did not know this. We will adhere to it to make code more portable. Additionally, it forces a certain self-discipline. If you have a large amount of local variables declared at the scope start, it will look cluttered. At the same time, it is usually a sign of bad program decomposition and the poor choice of data structures. Okay. That's interesting. Very interesting. Okay, it is if a variable in a certain scope has the same name as the variable already declared in a higher scope, the more recent variable hides the ancient one. There is no way to access the hidden variable syntactically by not storing its address somewhere and using the address. The local variables in different functions can of course have the same names. The variables are visible until the end of their respective blocks, so a commonly used notion of local variables is in fact block local, not function local. Yeah. Preprocessor. Here we go. Hey, somebody agreed with me about ternaries being bad. Melonhead says, I do not know how far you are into it, but as of now, how long would it take you to finish the language? Probably a little while. I'm not really sure yet. I mean, I have no idea, but there's kind of a lot to do yet so far, or still. Alright, C processor is acting similar to the NASM preprocessor. Its power, though, is much more limited. The most important preprocessor directives you're going to see are a year maybe from Melonhead. Maybe. I think like it's the kind of thing that's maybe not gonna be like finished before I start on the operating system, if you know what I mean. But I might use the operating system to kind of like dog food it, and yeah. But a year might be a good estimate. I don't know. But I'd like to maybe start doing the operating system before that, if I can. We'll see. Define, include, if, indef, and if. The define directive is very similar to its NASM define counterpart. It has three main uses. Defining global constants, my const value is 42. Defining parameterized macro substitutions, where you can do stuff like this. Defining flags, depending on which some additional code can be executed or excluded from sources. It is important to include parentheses all arguments. to enclose in parentheses all argument occurrences inside macro definitions. The reason behind it is that C macros are not syntactic, which means that the preprocessor is not aware of the code structure. Sometimes this results in unexpected behavior, as shown in listing 831. Listing 832 shows the preprocessed code. Gotcha. Yeah, that'd be bad. The include directive pastes the given file contents in place of itself. The file name is enclosed in either quotes or angle brackets. Okay. In the case of angle brackets, the file is searched in a set of predefined directories. For GCC, it is usually user local include, libdir that whatever, libdir, okay, user target include, user include. Using the -I key, one can add directories to this list. You can make a special include directory in your project root and add it to the GCC include search list. In the case of quotes, the files are also searched in the current directory. You can get the preprocessor output by evaluating a name filename.c the same way as when working with NASM. Okay. This will execute all. Okay. Summary. Let's do the summary. This chapter. Okay, we don't need to read the summary. Question 148. What is a literal? There's like string literals, and there's like identifier literals, and there's like floating point literals, and there's integer literals. There's all sorts of literals. L values and R values. R values is any expression that you can stick right here, and an L value is anything you could stick right here to the left of an assignment. What is the difference between the statement and expressions? Well, this is like a statement. This is like an expression. What is a block of statements? It's like one of these things. Well, how do you define a preprocessor symbol? You go like define foo to be 42. Actually, I'm not sure that you need it. I don't think you need a semicolon. Kind of like that. Why is break necessary at the end of each switch case? Because if not, it'll fall through to the next case. How are truth and false values encoded in C89? Just 1 and 0, or really 0 and anything that's not 0. What is the first argument of the printf function? It's the, where'd it go? Oh, it's the format string. Is printf checking the types of its arguments? No, it's not. Where can you declare variables in C89? Only in the beginning of a block scope and not after that, I think. Goodies, here's the type system. How long have we been doing this? Numeric types, typecasting, Boolean types, pointers, arrays, type aliases, the main function, operator size of, const types, strings, functional types. Oh, isn't the syntax for functional types really bad? If I remember correctly. Alright. Well, I think I'll probably stop there for now. Alright. Type system. Highlight this so I know where we were. Cool. Well, thanks everybody. We'll leave that there for now and pick back up probably tomorrow. So see y'all.